Hey guys, Mark from Dynex Hobby. Today I'm going to demonstrate how I can use a simple microphone attached to our PC to measure the vibration levels from a gas turbine. Now to do this, what we need is a USB microphone. In this case, this is a Zoom USB microphone. It's actually a stereo microphone. It's got two microphones which are directional, as you can see there. So there's the silver microphones, and they're pointing in the direction of the turbine. So we've got one pointing towards the turbine end and one towards the compressor end, and that's connected by a USB cable to our laptop over here. So just a simple USB connection to our TurboSCAN software, and you can connect to the microphone directly. As you can see, I've got the waterfall plots shown in the software. So what we're going to do is we're going to run the turbine up to full throttle and just take a measurement on the screen and have a look at it later on. Alright guys, now I've just taken a screenshot of the data that we recorded the other day, just so we can have a review.
So immediately on the waterfall plot, you'll see the compressor and turbine data. I've broken the data into a few stages. When we started the turbine at idle, you can see that there's this distinct red line on the compressor and turbine side. We suspect that's actually associated with what we call the blade pass frequency of the turbine and the NGV unit. So as the air is passing through the stators and then into the turbine stage, you start getting this whistling noise, which is quite distinct, and we all see that on the run up. So there's one solid red line, and then there are actually some lighter bands above that. As we ramp up the turbine, you can see that the line increases in frequency along the horizontal axis. So the horizontal axis is just the time scale as we run the turbine. So as we run the turbine up to speed, we go through the mid-throttle setting, full throttle, mid-throttle, and then ramp down again. So you can see on ramp up, the frequency is increasing as you expect for the compressor and turbine. You'll see a line on the bottom here, which is a very sort of shallow arc. It's common to the compressor and the turbine side, and that's what we call the 1x, or in other words, that's the running speed or running RPM of the turbine, and that actually shows up in the recording here as well, which is kind of good. A very thick sort of red line may indicate an imbalance condition of the turbine. You can see that the turbine stage has a slightly larger amplitude compared to the compressor stage, and we've actually seen that in previous recordings where the turbine has a slight higher of imbalance compared to the compressor side. Above this line, you'll actually see very shallow sort of lines in the mid-throttle. We suspect that is actually associated with the resonance or the critical frequency of the turbine, and that shows up as a very faint sort of signal here, which is kind of interesting. Above that is another line in the mid-level, and that is associated with the compressor blade pass. So as the air rushes through or past the blades of the compressor, it generates a tone. That's what we see there. So any sort of defects associated with the compressor, this might actually show up as more of a solid red line. On the chart, it's actually interesting to note that it's interesting to see the features coming out, but there's actually no bearing data. And the reason being is that the bearing data really is hidden behind this noise. The only way to actually get the bearing data accurately is to use a product like TurboSCAN. So just going back, TurboSCAN actually uses two accelerometers mounted directly to the case of the gas turbine engine, and that allows us to measure the vibration levels from the bearings on the compressor and turbine stages. So that's one of the reasons why TurboSCAN is so effective, because it's able to capture that data where you can't get that data through a microphone. Anyway, that's a quick overview on how you can quickly and easily use TurboSCAN to look at the health of your gas turbine engine, just using a standard USB microphone that you can buy online anywhere from Amazon or eBay. So I hope that helps explain or demonstrate the capability of TurboSCAN, and if you're really serious about the health of your turbine, please take a look at the TurboSCAN hardware, which is available on our web store. Okay, thanks guys.